Good morning to all. In this video, we discuss the points comparison between VCR and VAR system and the properties of the good refrigerant. First, we take comparison between VCR and VAR system. First point, working method. In a VCR, refrigerant vapor is compressed in the compressor, but in the case of VAR system, refrigerant vapor is absorbed in the absorber and heated. Next point, type of the energy supplied. VCR system works on mechanical energy, but VAR system works on heat energy. Next point, noise. In the case of VCR, noise is more due to the presence of compressor, but in the case of VAR system, almost quite in operation. Next point, work or mechanical energy required. In a VCR system, mechanical energy required is more because refrigerant vapor are compressed to higher pressure, but in a VAR system, mechanical energy required to run the pump is less, since pump is required only to circulate the refrigerant. Next point, coefficient of performance or COP. In a VCR system, although the COP is relatively higher, it reduces at part load conditions, but in the case of VAR system, although the COP is relatively lower, it will be more or less same at part and full load conditions. Next point, capacity. In the case of VCR system, the design capacity is limited since a single compressor unit can produce up to 1000 tons of refrigeration, but in the case of VAR system, the system can be designed to capacities well above 1000 tons. Next point, leakage of the refrigerant. In the case of VCR, due to the high pressure, the chances of leakages of the refrigerant is more and is a major problem. But in the case of VAR system, almost there is no leakages of the refrigerant. Next point, maintenance cost. In the case of VCR, the maintenance cost is high because of the compressor, but in the case of VAR system, it is less. Next point, operating cost. The operating cost is high since electrical energy is expensive in the case of VCR system, but in the case of VAR system, the operating cost is less. Last one, refrigerant used. The refrigerant used in the VCR system is Freon 12 or 22, but in the case of VAR system, it is ammonia. Next, we discuss the properties of a good refrigerant. First one, thermodynamic properties. In that one, first one is boiling point. The high boiling point of the refrigerant at atmospheric pressure reduces the capacity of this system, hence it must be low at atmospheric pressure. Second point, freezing point. The refrigerant should not freeze under the required evaporator temperature. It must have very low freezing point. Third one, evaporator and condenser pressure. Too high pressure in the condenser and your operator requires a robust refrigeration system and high initial and operating cost. Thus, for an ideal refrigerant, both condenser and evaporator pressure should be positive and slightly higher than the atmosphere pressure. Fourth one, latent heat of evaporation. The latent heat of evaporation must be very high. It increases the refrigeration effect. Next we move to the physical properties. In that, first one is specific volume. The specific volume of the refrigerant must be very low. The lower specific volume of the refrigerant at the section of the compressor reduces the size of the compressor for the same refrigeration capacity. Next, specific heat of liquid and vapor. It must have low specific heat when it is in liquid state and high specific heat when it is vaporized. The low specific heat of the refrigerant helps in subcooling of the liquid and high specific heat of vapor helps in decreasing the superheating of the vapor. Both these desirable properties increases the refrigerating effect. Next point, viscosity. It should have low viscosity in both liquid and vapor phases. This results in better heat transfer and low pumping power. Next, thermal conductivity. An ideal refrigerant should have high thermal conductivity in both liquid and vapor phases. Next one, safe working properties. In that, first one is toxicity. The ideal refrigerant used should be non-toxic because any leakages of the toxic refrigerant increases the suffocation and poisons the atmosphere. Second one is flammability. The ideal refrigerant should be non-flammable in the presence of air or in association with lubricating oil. Third point is corrosiousness. A good refrigerant should be non-corrosive to prevent the corrosion of the metallic parts of the refrigerator. Next point is chemical stability. An ideal refrigerant should be chemically stable and should not decompose under the operating condition. Next we move to the other properties. First one, odor. Even though distinct odor of the refrigerant helps in detecting the leakages, an ideal refrigerant must be odorless as it spoils the refrigerated products. Second point, COP. The COP of a refrigerant must be high so that the energy spent in the refrigeration will be less. Next point is action with lubricating oil. A good refrigerant must be not react with the lubricating oil used in the lubricating the parts of the compressor. Next point, leakages test. The refrigerant must be such that any leakages can be detected by simple test. Last one, cost and environment. An ideal refrigerant must be easily available and should be cheaper. These are the properties of the good refrigerant.